Okay, in this lesson, we're going to look at an introduction to right triangle trigonometry, and we'll do it by, we'll start by reviewing Pythagorean theorem, which is used when we have two sides of a right triangle and we want to find the third side. So the formula is a squared plus b squared equals c squared, where C is the hypotenuse of the triangle and it's the side, so then it is the side across from the right angle. One note here, and it's a naming condition used in trigonometry. We name the vertices typically with a capital letter, and that capital letter can then also represent the angle if there is only one angle at that point. And then the side that's across from it, we use the same letter, but we use the lowercase letter to designate the length of the side. So let's take a look at a couple of examples where we're using the formula. So in the first one here, it's a good idea to get in the habit of marking or drawing an arrow to where your hypotenuse is. It helps you to recognize how to use the formula. So x is the hypotenuse that we want to find out, so it represents the c squared in the formula. So we can say that 5 squared plus 12 squared equals x squared. So 169 is x squared, and we'll take the square root of both sides, so we get x equals 13. And in this case, we're only going to consider the positive square root of 169 rather than negative 13, because we would not use negative 13 to represent the length of a side of a triangle. In the second example, we want to solve for x where x is not the hypotenuse. So really we could write the formula as 20 squared plus x squared equals 25 squared. So we'll have x squared equals, and that's 625 minus 400, so it'll be 225. So x equals 15. Okay, so that's a quick review of Pythagorean theorem. Okay, so now we're going to look at the trigonometric or trig ratios for right triangles. And when we do that, we need to label all three sides of a triangle. And so we're starting with a right triangle, and as we did with Pythagorean theorem, we'll first consider the hypotenuse. Then there's generally going to be a reference angle, so one of the two acute angles in the triangle is the one that's under consideration. So from that angle, draw an arrow to the side that's across from it or opposite it, and that side we'll call the opposite. And we'll usually just write OPP for opposite. And then the leftover side is the adjacent. And if you think of adjacent meaning next to, it's a side that's next to the reference angle, but it's the one that's not the hypotenuse. So I highly recommend that you use that you label the hypotenuse first, then the opposite, and then the adjacent. Okay, so we're always thinking of the three sides of the triangle with regards to one of the acute angles. So there are 6 trig ratios. The first 3, sine, cosine, and tangent, you're going to see buttons for on your scientific calculator. Those are the 3 primary trig ratios. And then cosecant, secant, and cotangent are secondary. They're also called the reciprocal trig ratios. So let's look at what the definitions of them are. And they're ratios. So they're ratios of the sides in a triangle. So for instance, the sine of theta is equal to the opposite divided by the hypotenuse. Okay, cosine is adjacent over hypotenuse, and tangent is opposite divided by adjacent. Okay, and the reciprocal functions, or the secondary functions, cosecant is the reciprocal of sine, so it's the hypotenuse over the opposite, or you could think of it as 1 over the sine of theta. The secant is the reciprocal of cosine, So it's the hypotenuse over the adjacent, or 1 over cosine of theta. And the cotangent of theta is the adjacent divided by the opposite, or 1 over the tangent of theta. Okay, so that shows you the reciprocal identities of those three secondary trig ratios. So the value of a trig ratio, even though you're comparing the lengths of the sides, the value is actually dependent on the size of the angle, not on the size of the triangle. So if you have an angle of 23 degrees or pi over 4 radians, in a triangle, the sides will always have the same proportion if the angle stays the same. So here's a question. We need to find the 6 trig ratios for theta. And I haven't labeled theta here yet, so we'll label it there at angle C. So we want the 6 trig ratios, so we need to think of what the 3 sides are. We have values for side C and side A, but we don't have a value for side B yet. So let's calculate that first, and we go back to Pythagorean theorem to do that. So since it is the hypotenuse, we can say that B squared is 7 squared plus 24 squared. So that'll be 49 plus, I forget what 625, sorry, what 24 squared is, but together they come to 625. And so B is 25. Okay, and that is the hypotenuse, so we'll call it that. Theta is our reference angle, so we'll go across from there, and so C, or with a value of 7, is our opposite, and A with a value of 24 is our adjacent. So now we can fill in what these 6 trig ratios are. We can say that the sine of theta is opposite over hypotenuse, so 7/25. The cosine of theta will be 24/25 adjacent over hypotenuse, and the tangent of theta will be 7/24 opposite over adjacent. The reciprocal functions will just be the reciprocals. So we've got cosecant will be 25/7. I'm not looking at my triangle to get these anymore. I'm just looking at the sine, cosine, and tan and flipping them. Okay, so the secant is 25/24, and the tangent, sorry, the cotangent of theta will be 24/7. Okay, now there's a couple of mnemonic devices that you can use to remember what the trig functions are, and it's really important that you have memorized what sine, cosine, and tangent are, and then you can, these secondary ones are not, you don't need to memorize so much as remember that they are the reciprocals. So this is a device that a lot of students use, and they memorize this word, SOHCAHTOA. So the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So memorizing SOHCAHTOA helps you to keep in mind which is which. So let's look at one more question. So again, I have a triangle. I need to find the 6 trig ratios. My theta is up here at angle D. So side E, which has a value of 5, is my hypotenuse. Side D across from the angle is my opposite, and I don't know its value yet, so I'm going to have to do that. And then side F is my adjacent. So let's find the value of side D first. So we can say, using Pythagorean theorem, that 1 squared plus D squared is equal to 5 squared. So D squared will be 25 minus 1 will be 24, and we always need to express that in still exact terms, but in simplified form. So D is the square root of 24, or 2 root 6. So there's the simplified radical form for the value of d. All right, so now let's take a look at sine of theta, cosine of theta, and tangent of theta. Okay, so you may want to press pause here and try these three, and then press play and check if you've got those correct. Okay, so for our sine, it's opposite over hypotenuse, so it's going to be 2 root 6 over 5. Our cosine will be adjacent over hypotenuse, 1 over 5, and our tangent is opposite over adjacent, so it'll be 2 root 6 over 1, or just plain 2 root 6. So now let's look at our reciprocal functions. And again, if you want to press pause and try them, give it a shot. Cosecant is the reciprocal of sine, so it'll be the reciprocal of what we have here, so it'll be 5 over 2 root 6. However, we can't leave something in this form because we have an irrational number in our denominator. So we'll multiply top and bottom by root 6, and we'll have 5 root 6 in our numerator. Now let's look at the denominator. I've got root 6 times root 6, which gives me 6 times 2, which is 12. Okay, so we always simplify it, but leave it in exact form. So the secant of theta, the reciprocal of the cosine, will be 5 over 1, or 5. And the cotangent, which is the reciprocal of the tangent, will be 1 over 2 root 6. And again, to simplify that, we'll multiply by root 6 over root 6. So we get root 6 over 12. It's really important that you figure out how exactly you're going to memorize those 3 trig ratios. There are different mnemonic devices besides SOHCAHTOA, and you may want to investigate one that works really well for you as you continue to work through this material.